This is a short video of a tabletop fire pit project I put together. The idea was I wanted a small fire pit that I could put on a wood patio table or on a deck and not have to worry about it burning the wood or people getting third-degree burns. It does look a little Game of Thrones, but there is a lot of logic behind the design. So if we're to look at just the burner itself, you can model the heat transfer from it to whatever the heck it's sitting on, just using the Stefan-Boltzmann equation. And that equation basically says that the heat transferred by radiation is equal to the emissivity, which is epsilon, times Stefan-Boltzmann constant, which is sigma, times the total cross-sectional area, A, and then it is the temperature of the radiated surface to the fourth power minus the temperature of the irradiated surface to the fourth power. And so here I'm just sort of replicating this geometry of the burner thing here in Excel, and I'm just typing in all the general values. And then I'm just using this equation here and here for the heat transferred from the burner plate to the wood table, and then the wood table to the surroundings. And I'm summing these up, and then I'm just going to solve this using the GRG solver in Excel. So let's click on that, set that equal to a value of 0 by changing our temperature. I just put initial condition in of 800, click solve, and we get a value of 152 degrees Celsius. Looking at the total design, where it's this burner sitting on this other bottom plate thing here, still use the same fundamental equation, except we have to modify it a bit to include the total heat transfer path, where it's going from this burner to what I call the ash plate, and then to the wood table, and then irradiating out to the surroundings. So it's similar concept, except now we just add all these terms here in the bottom to account for the different emissivities, the different areas, and then the F is the view factor. And so I got all these values just thrown in right here, and then same thing as before, you can just throw in an initial value, use our solver where we set our sum of these two equations equal to 0, and change our temperature, solve, and you can see we get 96.5 degrees Celsius. And what's interesting is that if you look at these equations and you kind of break everything down, you can see that every time you add a heat shield like this to something, it actually cuts your heat transfer rate in half. And this is the same reason catalytic converters have these very thin sheet metal shields on them, is because it really does a surprisingly good job of insulating them from the outside environment and not, setting stuff on fire when you drive over it. So from our results, we can see that we've dropped the temperature by about 55 degrees or so by just adding this little bottom plate here. And this is a relatively simple estimation just based on, very basic rate of heat transfer. There's going to be a lot of other stuff happening too, like you're going to have heat transfer from the walls of the ashtray thing here, and as well as radiation over a larger surface area to the wood table or deck or wherever the heck is below it. So in reality, 96.5 degrees Celsius should be the maximum temperature that we really see. So we should be pretty good as far as not catching things on fire. So with that, let's actually look at the building of this thing. So the whole thing is constructed out of some kind of hot rolled steel plate. I think it was 1018 or something like that. But I started out with doing a lot of cutting with just some cheap Harbor Freight cutoff wheels. And it made quite a mess, but I'm too cheap to buy a plasma cutter, so it works. So after getting everything cut and deburred and cleaned up, I took the parts over to the mill and started drilling a bunch of holes for the burner. The holes are there to allow some of the heat to get out and to actually see what's going on inside. But they're also there to sort of help keep the heat in. Since it's not a very large burner, you don't want a gust of wind coming along and extinguishing the fire or blowing a bunch of ash or anything like that out. Here I'm just sliding out the material which is going to create the legs for the burner when it sits on top of the ashtray. Then after everything was cut in the mill, I put it all together and then started TIG welding. This is the only halfway decent looking weld on this whole thing. And so here's the completed project. I've had this fire going in here for about a half hour and the sides are still cool to the touch. So mission accomplished. And here's a shot with the IR camera where you can really see how well that heat is radiating off of that ashtray and really keeping that bottom and base cool and not allowing that heat to transfer from the burner itself to the piece of material that the thing's sitting on. And that's all for this project. Thanks for watching.